Welcome, ladies and gentlemen. Welcome here to the forum of the group exhibit, Hydrogen Fuel Cells and Batteries. Please stay here, have a drink on the house, discuss with us, listen to the next interview here on stage. We will talk about economic benefits of non-PGM catalysts, and that means non-platinum group metal catalysts. So we talk about costs of PEMs, and I am very happy to have here with me the chairman and CEO of Pajarito Powder from Albuquerque, New Mexico, Tom Stephenson. Here he comes. Please give him a hand.
Thank you.
Good to have you here, Tom.
Thank you very much.
So whenever you like, just raise your hand if you have a question, if you want to participate in this discussion, if you have any question to Tom, so just let me know. I'll be with the microphone right with you. Tom, I think here on this group exhibit, it's all about hydrogen, about fuel cells, and they only have three big problems. And the three big problems are first costs, second costs, and third costs, isn't it?
Absolutely.
Okay.
And that's the founding principle for our entire company, because our belief is that the move towards non-PGM catalysts will allow us to have a very substantial effect on the overall economic cost of delivering PEM fuel cells.
That's the problem. If you have a PEM fuel cell, you still have a catalyst in it, and it contains platinum. But what's the problem about platinum?
Platinum is too expensive.
Yeah, that's the most, and it's sounded,
we say that
isn't
a lot.
it? Yeah, you have to say that. It's too expensive. What's the price of platinum at the moment, you know?
Right, so platinum today is running about $1,200, $1,250 US per troy ounce. It'll be in the low $40 per gram.
So it came
actually
down a little bit, didn't it?
It's relatively inexpensive at the moment. Yeah,
okay,
that's right.
Yeah. So
exactly.
You better buy a lot of platinum now, because in 10 years' time it's going to be much more expensive. What do you think?
Well, I mean, you don't have a nice stash in your garage somewhere in platinum, because then that price goes back up. Yeah, exactly.
Okay. So why do we need platinum in a fuel cell? Why, we could use something else.
Platinum is a fabulous catalyst, and to be very clear, it's still, platinum catalysts are still the best materials for promoting, particularly on the cathode side, the oxygen reduction reaction in PEM fuel cells. And so it's been the traditional choice to use for catalysts. The fundamental challenge is that it's too expensive, and it has continued to keep up the cost of PEM fuel cells. It has the secondary problem that, unlike every other component in the fuel cell, there's no way to gain benefits of scale. If it requires a certain amount of platinum in one fuel cell, it's going to require X times that many grams of platinum for X fuel cells. And so there needs to be a solution that allows you to ultimately deliver a better cost at scale. And
it's going to be the other way around, actually. If the automobile industry is producing PEM fuel cells at large scales, price for platinum will probably rise.
Right. It's standard commodity pricing. As that demand goes up, we're going to see an increasing amount pressure on the pricing to ultimately take it up. And so, that suggests that a new solution would be the right answer to eliminate our dependency on platinum altogether.
But a fuel cell stack does not only consist of the platinum catalyst, does it?
No, of course not. I mean, but what's interesting is that the platinum catalyst still represents even today represents a disproportionately high percentage of the overall cost in the fuel cell. As much as 30% to 50% of the fuel cell stack is captured in the platinum catalyst in the fuel cell. And as you talk about the economies of scale driving down costs in the bipolar plates, in the membranes, in the other components of the balance of plant, that percentage of cost is just going to go up, and the problem is becoming worse and worse.
So you are the world's first commercial manufacturer of drop-in replacement non-platinum fuel cell catalysts. What do you mean with drop-in replacement?
So the main point of what we've tried to do is our approach with our non-PGM catalysts is to eliminate as much as possible design changes that would be required by the fuel cell stack manufacturers. Mm-hmm. And so when we talk about a drop-in replacement for platinum on carbon fuel cells, it means that, and there are changes that have to be made, but fundamentally you're going to produce, it's the same black powder, and I brought some with us. This is our catalyst material, and it looks very similar to what platinum on carbon would look like. You make the same inks out of it. You use the same processes to do that. You use the same manufacturing. You just replace the platinum on carbon, and every other step in the process is the same that ultimately takes you to the fuel cell stack.
Okay, and the U.S. Department of Energy for Transportation has said, well, we have some goals for prices. What are these goals? Can you tell me?
Yeah, so one of the things that the United States Department of Energy does is to set these projections and targets for the overall cost that they believe is necessary to see broader adoptions. And I think that that everyone in the industry that you talk to is suspicious about whether or not these costs really reflect where the industry is, but they at least provide us with a target that we can talk about. And the 2020 target for the fuel cell system is $40 per kilowatt, and the target for the fuel cell stack by 2020 is $20 a kilowatt. And one of the things I want to point out is I think that the Department of Energy is doing this right because they're measuring the cost in terms of the cost per power output, not the cost per individual component cost or cost per gram of catalyst. But what this means is that if you're talking today, that the likelihood that the catalyst is contributing as much as $15 or $20 per kilowatt, they're going to need to get that number down to more like $6 per kilowatt, which is going to be a very challenging thing to do with platinum in the fuel cell.
You always have to look at the output in the end. I just can't say, well, how much is a pound of platinum and how much is a pound of your material. That doesn't make any sense because you need some more of your material.
Right.
So we look at the output, at the watt or the kilowatt you can produce with the stack.
Right, and so for us, the measurement is always around US dollars per kilowatt, and with our scale at our manufacturing at scale, we've got the ability to produce the catalyst at $3 to $5 a kilowatt, which will get nicely into that range.
I would like to offer you, if you have a question, just raise your hand. I'll be with the microphone right with you. So if you put a question to Tom, just feel free to do so. Well, I would like to know, this material you brought with us, it's black.
Oh, okay. Don't shake it so hard.
Oh, okay, sorry.
I'm kidding.
It might explode. No, okay. What is it made of? Probably carbon.
It is predominantly carbon, and of course we have other materials that are in there, and the exact process and formulation is proprietary. But we do provide information on the composition, and the vast majority of it is carbon. It does have other base metals. We have different formulations depending upon the specific needs, but it's going to be carbon, nitrogen, and then a transition metal like iron and cobalt or manganese.
Okay, you need the iron, or could you pit the iron out?
Well, it's very interesting because iron is a bit of a bad player in some fuel cell stack designs. And so one of the things that we've done at the request of our customers is look at how we can actually eliminate the iron. And so we have formulations that are completely iron free. Our base product is made with iron, but we can make it, and the amount of iron is less than 0.5% typically when we're done doing the manufacturing process. So it's still just very much trace amounts of the transition metals, but we can do it entirely without iron as well.
So let's talk about the price in comparison to platinum catalyst. How much cheaper is your product counted in kilowatt, as we just pointed out? Yeah.
So again, I mean, if we talk about it in terms of the power and the dollars per kilowatt, the projections for the platinum catalyst vary a great deal, but it's difficult. There's certainly a floor associated with that's just based on the overall commodity cost of the platinum. But I think that the expectation is it's going to be very difficult for them to get a number that's getting down south of $10 per kilowatt, whereas for us, we can look at $3 to $5 a kilowatt in a fuel cell stack application ultimately.
Which is quite nice if you can do that. I've had a look on your website and saw this cost curve. So this year you're still more expensive than platinum is, and
right.
Next year you get the break-even point, and in 2017 you much cheaper. Where are you right now, actually?
So we're actually a little bit ahead of those curves right now, and that's one of the things that's very exciting about this as a product is that it does have the benefits of scale. And so as we look at implementing more efficiencies in our manufacturing, and actually the biggest piece is if we just start buying our precursors in larger quantities, we're able to drive the cost down very dramatically. And so based upon that, where we are today is at a place that we believe is price comparable with platinum on a price per kilowatt.
And what will drive your costs down in the future? What are your plans?
We need to buy more. So it's our CTO is here in the audience, and he really would like me to buy rail cars of the precursor material and stack it outside the plant. But we don't quite have the demand for that yet. When we do buy it by the rail car, we're going to be able to start to see some real significant drops in our overall cost. Beyond that, then it just becomes a question of the larger batch sizes that we'd be producing and some more equipment that allows us greater efficiency in the distribution of the overhead and quality control across a much larger volume of manufacturing.
Maybe he is right. You should buy more of this material, then you can sell more because you're going to be cheaper very, very quick.
Well, the really great thing about the stuff that we're using is that the applications for fuel cells represent a very small percentage of the overall demand. These are products that are used, they're precursors and chemicals that are used in a variety of sort of standard manufacturing, and that even at the most wildly optimistic assumptions about fuel cell adoption, we wouldn't really put a dent in the overall demand for those precursors. And so we're not going to drive that cost up like you see with the potential for platinum.
Okay, but the material is here, you sell it also, but who will sell it for large production? Most will say, well, let me try a little bit, and we make some tests with it, and then we'll see if we buy more.
It's a design in process, and so our expectation is that there'll be qualification, and that's what we're doing with our customers today. And by and large, they'll take a small sample and use that for initial evaluation, and then start to move that through a process ultimately towards commercial production. And we expect that and are able to support that in terms of whatever level of demand they need. We also have the ability to tune the formulation depending upon the particular needs of the customer, and so part of that becomes an iterative process. And so if a customer comes back and wants a porosity level that's a little bit different or a slightly different formulation, we're able to support that as well.
So you help your customer also with designing the mirror and
it's really just the catalyst, right?
Okay,
I mean, to be very clear, so we're catalyst specialists. Now, we do what we've learned over the course of the last year, since we were here last year, is that there's a tremendous amount as well, and anybody who's vested in the fuel cell industry will know this, around membrane electrode assembly construction as well. And while there's been a tremendous amount of work that's been done historically on the platinum on carbon catalyst, there's been a lot less that has been done for non-PGM. And so we are certainly working with our customers and partners to come up that learning curve and being able to build optimized MEAs for non-PGM. And we're excited about those prospects. We're seeing improvements in performance based upon that on a regular basis, but we're still definitely learning there.
So what I've definitely learned is that your powder is much cheaper than a catalyst made from platinum, but it has some disadvantages. We have to point that out. What are the most problematic disadvantages?
Well, I mean, let's be clear that it does not have the same performance on the mass activity level as platinum does. We've never claimed that. We don't believe that we're going to hit that point. And so if you're a fuel cell systems manufacturer, a stack manufacturer, you have to understand that going in, and understand and look at where there may be sort of trade-offs in the balance of plant, in the system, in the stack, that you can be able to offset that depending upon what the needs are in terms of your overall power density. Beyond that, I think our biggest disadvantage is that we don't have the history, and therefore we've not done as much field testing as has been the case with platinum and carbon catalysts. And so we don't have the same long-term tests that have been done. The tests that we have done suggest excellent stability. Our durability is very comparable to platinum on carbon, but we still need to continue to build that base of testing over time.
So you can say something about reliability, durability of this.
Yeah, material. I mean, what we can say is that based upon all of the work that we have done to date, the stability is very good, over hundreds of hours, and the durability is comparable to what we see with typical platinum on carbon catalysts. So if you run it through an accelerated stress test like the automobile industry does, you see the same effect in terms of the drop-off of the performance for our catalyst as you would see for a platinum on carbon catalyst.
But if you need more of your material, you probably need more fuel cell stacks to get the same power out of it, and that's a matter of place, of volume, and weight, isn't it?
Well, right. And again, this comes back to sort of a question that is much more at the stack and system level, and is for those customers to decide, because there's a lot of different levels that you can potentially look at. I mean, we do higher loadings of our catalyst than you would do in platinum and carbon, which is okay, because on a per gram basis it's dramatically cheaper. But you can also look at changes to pressure. You can look at size. It's not just a question of, well, okay, this means we're going to need to add we're going to need to add more bipolar plates at the end. There are other opportunities to make adjustments that will allow you to offset that from a power standpoint. But there's no question that there are going to be some design considerations. I think for us, though, it's really about the question of what's the overall economics of the fuel cell. And I think we've been driven very much around the idea that there has to be a maximum power density that gets achieved. And to us, it's about the overall economics of the fuel cell, meaning delivering the right level of power density for the cost that's required in the marketplace. And if we're going to ultimately be successful with the commercial adoption of fuel cells broadly, whether it's in motive applications, whether it's in CHP, whether it's in backup power, is we're going to have to see those costs come down. And that inevitably will mean certain trade-offs that have to be made. And one is that we make available for the first time in commercial quantities a product that has the type of performance, the type of stability and durability that becomes a potential substitute for platinum on carbon catalysts.
But I couldn't imagine that the dream application for you would be automobiles who have PEMs in it.
Absolutely,
and they need a large amount of your powder then. But on the other hand, you have to care about the volume and weight, especially for the automobile industry.
There's no question that the car application is probably the hardest one, because they've got some of the highest power density requirements, and therefore there are likely to be some interim steps for the automotive industry where we've been able to use similar formulations that are supported by very low levels of platinum to provide better performance over the short run. But if you talk to the automotive industry customers as we have, they understand that there's going to be, the economics are going to drive large-scale adoption. And while that's not the critical consideration with the Gen 1 version of the products that may be out there today or that are being released in the next year or two, they're going to start to increasingly become critical when you talk about future generations and larger volumes of production.
Any questions from your side? So just raise your hand. I'll be right with you with the microphone if you have a question. So my last question is, Tom, do you have any competitors?
We do, and it's sort of interesting because we've seen the development of some competitive players just over the course of the last year, which we view that very much as a positive. If that means that the others believe as we do that the time is starting to get right for non-PGM catalysts, that they're getting to a level of activity to potentially be realistic candidates for substitutes in certain applications. And so without that, we'd probably be a little bit nervous. But the fact that there are a few out there is good. I think we've developed the first ones that with commercial scale production where we can take orders today. And so we feel like we're still out in front, but there's definitely competition coming.
Competition is good for the market, always.
Good.
Indeed. Okay. Thank you very much for having talked with me. 20 minutes are already over. I can invite you, everybody of you, to the booth of Pajarito Powder, which is at C34/1, right down this aisle next to the technical forum.
Exactly.
Right. And you find Tom there and a lot of his colleagues there.
If I can give a plug, we'll have a technical presentation at 3:20.
All right.
By my colleague, our president and CTO, Dr. Barhaleve, will be talking in more detail about non-PGM catalysts.
Perfect. Thank you very much, Tom, for having you here. And thank you very much for your interest. Thank you.
Thank you.
It was a pleasure. So the next event will take place here in 1 minute. It will be an event in the public forum at 1:40 with Jürgen Rechberger. He is manager Fuel Cell AVL List GmbH about the AVL Fuel Cell product portfolio. And I see he's here already, so just stay tuned. We will continue 1 minute time. Thank you.